Well, hello and welcome back to Dad's Shed. What are we doing today? Well, as you may recall, if you watched a number of the videos, I picked up a few issues with my Tom Senior milling machine, and using the large Clarkson chuck I have that fits in the International 30 spindle, I'm getting quite a bit of run out, and its total is about 8 thou. And that makes the cutters obviously oscillate and wobble, which rather ruins any chance of cutting anything accurately. And I've checked the spindle, and I've checked a number of other slightly smaller cutters I have, and they're fine. It's, something like this one here is running beautifully. So I've got 3 or 4 arbors I can put in there, and or chucks rather, and all of them running fine apart from the one I need. So as I need something that will actually hold the cutters for the gear blanks, and I need it to run concentrically, I need a stub arbor to go in the mill, and I thought I'd found one. And as I mentioned, I spoke to a very good company in the Midlands about getting hold of one. It was on their website. I ordered it, and they came back and said, that's the website that shouldn't be in use. We don't have them, and the last lot we had weren't good enough, so we sent them back. So it's going to be about 3-4 months plus before they get them in. So I just happen to have a large lump of steel sitting around, which I bought just in case a while ago. So what I'm doing now is setting up the lathe to turn the 30 International taper. But before I do that, you may have noticed in my last video there was something missing on the lathe, and that was the reader for the x-axis, but it's now back. And as you might be able to see on this little bit of video here, it's attached on the back of the cross slide here, and I've used the tapped holes I put in the top, and it goes out straight out, and then I have this little bar that comes out here and locks the reader, and that uses the holes I tapped in the top of the cross slide itself. So that's been checked, that is running beautifully. So I'm now happy, and I'll put that away, that I can measure accurately feeding in, which is going to be very handy. So I thought I might as well spend a couple of hours getting that sorted out first. I've needed to drop the splashback back a bit, which required drilling a couple of extra holes to lever it out slightly. That's not a problem. I've moved my tool tray up a bit and clamped it at the top of the splashback rather than a bit further down. Didn't take very long, but it's done, and I can now use this with a working readout, and at the same time have the compound side set across at an angle. All good. So where are we now? Well, I've come in a bit late on this one because it's taken me a little while to get this sorted, but I've now got a dial gauge on the taper. I've put it in the chuck, and I've held it very carefully and checked that it's running around, which it is, and I can now move this backwards and forwards, and there's no movement on the dial gauge. The only movement is as you traverse and start from going backwards to forwards, it moves a little bit there at that point. So what I'm going to do now is just tighten this up a little bit. I'm going to check it again, because as I found out the other day, when you tighten this up it does move things a little bit. So I just want to make sure it doesn't alter the angle. No, that's running fine. Right, no movement on there. So I now know I have no movement, and that this is running accurately compared to that taper. So I can now go ahead and start to set up to machine the rather large piece of steel I have sitting down here. So I need the enlarged fixed steady I built to turn down one end, centre it, then do some more machining, put the fixed steady back on, centre again, and then drill, tap, or probably screw cut actually, for 1/2 inch Whitworth for the holding bar. Then machine it down to make, if I can find where I've just put one out of the way safely, to make, where we got that piece, and that piece will then go into the 4-jaw. I can then set that up to run that accurately, and once I've got that done and it's that way round, and I can then machine all these other parts. Then I can machine the taper, and then I can come back here and machine the nose, the 1 inch section that will take the cutters. But what I will do is I am not going to machine it to full size on here. As I've learnt from looking at other things, what I'm going to do is machine this to within about 10,000ths, so about 1.01 of an inch, and then take it over onto the mill, put this on the mill, take my tool post over there as well, and use the mill as a lathe and take the last 10 thou off while it's running in situ. Everything else will be done on the lathe, all the screw cutting will be done, but the last thing to do, last but one, is to take the thing over to the mill, mount it up, and then using the mill as a lathe, machine down to a dead 1 inch to take the cutters, and then cut the keyway. So that's the plan. Yeah, that's the plan. So hopefully we'll get somewhere with it. But at the moment, that will do, and we'll crack on and get this set up to machine the lovely little piece of EN24. Yeah, that's going to be fun. See you in a while. I've just set this up in the outside jaws on the 3-jaw chuck, and it's sitting in the fixed steady. So the plan now is to machine down this end to the same rough size as that. This is very much roughed out at the moment. Put a nice deep big centre in there, because I then need to go in, drill and tap 1/2 inch. Before I do that, let's put some juice on there. That's not what I wanted to do. Just pulling it out of the chuck. AISI is getting silly. So I've put this chunk of EN24 in. I've turned and faced the end here and put a centre into it. I'm now going to drill through, ready to partially screw cut and then tap 1/2 inch Whitworth, and then I'm going to make sure the outer edge of that is also chamfered so that I can get a centre into it. So there's a fair bit to do on this. Okay, that's gone down to 75mm on here, but I started at 10 rather than 0, so I've got 65mm hole depth there, which gives me 10mm clearance over that that's in the other chuck. So that should enable me to go through roughly as I want. But what I'm going to do is I'm going to get a countersink bit, and I'm going to put the countersink bit in there. Drop that right down. Let's go to 200. That's better. That's got rid of any little chatter marks. Now, the theory is, I always like theories. Theories work really well. It's only when you get into practical aspects that things go horribly wrong. And I'll drill that out a bit further. I'll take a 10mm drill bit to that, I think, and then see where we can go on there. I have got the right size drill bit sitting over there to do this. Unfortunately, it's one of a set I bought. And some of you may recognise these sets. They are readily available, and I have to say that unfortunately they are almost invariably useless. Every single time I've tried to drill a hole out with that, it has basically melted the drill. So I'll go back to my dormers. Thank you very much. Okay, let's get a bit of this on here. I've gone through, I found a 27/64 drill bit, which is almost dead on the size I need to tap 1/2 inch Whitworth. So I'm going to see where we go with this. I've got the speed down to about 200 RPM. Plenty of coolant. 40mm deep, so that's not going too badly. Okay, that's down to the bottom. Well, that's gone through okay, so I'm quite pleased with that. But these drill bits, they're really useful, not very good. You have to run them at a very, very slow speed. Anything above really, really slow, they just go. And even on this, running at 200 RPM, I can see on the right on the edge here that there's a mark coming where it's dulling it. Okay, what we'll do now is get set up with the internal threading tool and do this. I think I'll probably thread this coming out. Before I do that, I'm going to put a 1/2 inch drill in here and just give myself a little relief at the end. And then I should know where I'm starting from. Well, hi, we're back on the lathe. What I've done here is I've drilled through 25/64, which is 10.6mm. I've put a little bit of 1/2 inch clearance through at this end, just about 1/8 of an inch, and then I'm just put a 1/2 inch Whitworth taper tap in. And I'm just going to persuade it to go through, which it will do, I think. Yeah, 1/2 inch Whitworth is not one of the easiest threads to tap, I must admit. I have just gone along the cutting face of the taps with a slipstone, just to give them a little bit of sharpening up. Let's try and get this one out. I've got another one here. See if that goes any better. Of course, none of these Whitworth taps are actually very new. This is a Hercules brand, which I have never heard of, to be honest. Let's put a little bit of cutting paste on here. It's bright green, so it should be good. I am joking on that. No, this is Trefolex, which has always been one of my go-to cutting pastes. I've always found it very, very good. And why, you may ask, am I tapping this hole, or trying to tap this hole, so early in the proceedings on this job? Well, excuse me, once I've tapped this and I've got a taper in there above where the hole is tapped, I can then put the running centre in, and then I can start to take this end down to its final dimension. I can then flip the whole thing round, hold it by that end in the chuck, or hold it by this end in the chuck, use the centre that's already in the other end to hold it, and then I can start to take down the section that will become the 1-inch arbor, and then I can look to cutting the taper. So the taper is already set on the compound slide, so everything else can be done without altering that. So the idea is to get this done, take this end down to wherever it's gone, to the size I need. So that will be that section there, and once that's in there, I'll hold it in the forejaw, take this end down, obviously this bit needs to stay, then machine down the actual 30 International taper. But first things first, let's get this tapped for the drawbar. I'll bring you back when I've got a bit further through this. We are getting there. I'm not sure where, but we're getting there. I am cheating. There's a surprise. I have found a length of tube which fits nice and snugly over here, and I'm doing what I shouldn't be doing, which is using it for extra leverage. I have actually got a bigger tap wrench. Unfortunately, although that gives me the leverage I want, it doesn't give me the clearance over the bed. So with this I can actually do it up, come back off, bring it around to the other end. I've got lubricant in there. And this is always a bit of a nervous moment for me, because I'm used to working with things like 4mm and 6mm in what I used to do, and 1/2 inch Whitworth is a completely different beast, and the sort of torque I can put through this 1/2 inch tap is completely different to what I could do with 4mm. I'm actually getting fairly close now to being at the bottom of this hole with this tap. I don't need to go much further than I am already, so I'm just going to do another couple of turns. I'll feel when it hits bottom, obviously, and I would say that's probably about there. Okay, that's the taper tap in. That's the hard work done, I hope. Well, that's my taper tap sorted. Let's give that a little dunk in some oil. I will also blow it out, try and get any rubbish out of there. Well, that's what comes with relatively cheap cast aluminium. Right, that is tapped through. I now have about 1/8 inch of clearance before the thread starts, and at the top of that I have got a countersink that will match my, let's hope that's actually going to be big enough to, oh it does just, that's handy. That means my smaller live sensor will sit in there. And then I can get rid of that. That's it, fixed, then it can come out. And then it can go back in its home, ready for the next time. Okay. Right, that will do. I'll put that up there as a reference. That doesn't like that. Let's go for a slightly finer tipped tool, I think. That should do the job. Doesn't like it. Okay, that's as far as I can go with that tool, as it's now starting to impact the centre. So let's see if I go to the smaller centre, how far I can get away with that. Well, that's not going to make a lot of difference with that tool, so I'm going to have to change that out and go over back to this one with a different and change the bit. I'll come back once I've changed the now rather blunt. .22 dead. Okay, lovely. X22.0, enter. Right, so that's 22, 5mm to come off. I'll take these at 1mm cuts, I think. Okay, well that's looking quite reasonable. I can now take this off and put the bigger centre in. Because I've got quite a lot now to take off of here. Let's take this down as well. Now this is about 65mm. I need to take it down to 61. That says 70mm, so So I've changed tips. I've gone to a WNMG tip here. And I've got to remember this is not mild steel. This is an alloy steel. It doesn't like taking a 1mm cut. it's only accepting a half mil, so 1 mil off. I'm running it currently at 800 RPM and 4 thou per rev feed. That's not bad. Finish is quite reasonable. Obviously 6 thou is taking quite a lot more off, but it's going to be going through that. So I'll carry on with this. I won't keep showing it because it's basic turning and you've seen it all before. I'll come back when I'm down closer to my finish size, which is that one across there. I'll do it on this camera, you might see it a little bit better. That piece across here, and 31.6. We're currently on 57, so quite a long way to go. I'll bring you back when I'm closer to it. See you later. 34.98 mil, and that is telling me 34.99, so it's 0.01 of a millimetre out, so I can accept that for the moment. We're going to take this down another 2 mil, so another 3 mil to 32 mil. The final size I actually want is 31.8. And if you can see me through the fog, I'll do a little bit more of this. And one thing I have done in hogging this down is created an absolute rat's nest of swarf. It's everywhere. Let's see if I can just grab some of that. And I know I shouldn't be doing it with my hands, but that can go in the sack, and then I can look to drop that off into a swarf skip. Right, now .98, so that's 0.1 above where I actually want to be. That's fine because I can take that down once I flip this round in the chuck and done the other end, and that will be part of the machining of the taper. So that one I'm happy with, so I can now move my dead stop, take those out, that's that. I'll re-engage the dead stop there so I don't run it into anything into the chuck doors. that was a hot chip that just came up into my hand. Tell you what, this is definitely hotter than my tea. What are you reading there? Wow, that's reading exactly the same as my DRO is. There's a shock to the system. Right. Okay, that's pretty much where we want to be. But what I will do is I'll get my phone out and let's have a little look at the swarf. So piles of swarf, there you go. And I'm nowhere near done yet because I've still got to hog down that end from about there. Have a nice collar to take the drive dogs, and then that's then got to go down to just over an inch with a 7/8 by 20 TPI thread on the end 1.5 to take the holding nut. Right, I'll reset this t'other way round so that I can start cutting this end. Right, I'll see you shortly. And hopefully the fog will have dissipated a bit more and you can see things. See you in a minute. Slight addition here with the bump cap, not to avoid bumps but to try and keep the hot swarf off my head. Long way to go. This is currently sitting around about 54 mil. I'm going to take it down to 25.4. What I'll do is I'll work my way through the fog and I'll bring you back when I'm a lot closer to the finished product. And at the moment these are roughing cuts. Morning. Well, this is now cooled down, so I've just run the micrometer over it, and as I suspected last night, or yesterday afternoon, with the heat that was at, it had grown slightly. And now it's about 9-10 degrees C, and it's actually dead on 26 mil. So it shrunk by 0.3. So I now only have to take off 0.6, and that will take me down exactly to the inch size I want. So the next little bit is, and I've given a mark there, and I don't know whether you can actually see this on the screen, but the cutting paste and oil I was using yesterday overnight has given a really nice rust looking coating, but it's not rust, it's oil. It's got a very light brown, but that will come off as soon as I do anything to it, so I'm not too worried about that. I'm now going to take this down to 7/8, which my little chart on the wall tells me is 22.23 mil. So I've written that on my whiteboard. So I'm just going to take this down now to 22.23, and that there is 26. So let's go down a little more. A quick remeasure. .86. I just want to take that into 22.23. Right, picked up my reference tables to check the thread depth that I need. One of the sources of information is the Zeus book. But this one is a little different, and if I open it up, the Joint Committee for Soviet Aid, and what you've got on the front of here is someone working a mill, a LNER A4 Pacific, a Spitfire, and I can't find a date on this, but it's obviously somewhere about 1942-43. So they carry on. Okay, that's gone down 0.8, so that's 0.04 depth, 0.08 off the diameter. That gives me a little bit of headroom at the bottom. So, next thing is, and I'll do this off camera because you've seen lots and lots of videos of doing this, I'll bring you back once I've got set up to do the screw cutting. See you in a moment. It's amazing what happens when you forget to press the record button, isn't it? I've just screw cut this down. It's a 7/8 by 18 TPI thread, single point threading it, and part way through my digital readout decides it's not going to read any longer, so I've done it off of the hand wheel, which is 1.8 mil. So that's now down to depth, and obviously as I'm going to be making the nut, I'll make the nut to fit. Right, next thing is break this down and then set this up between centres to look at cutting the angle of the taper. So I'll take the centre off. I've just put the fixed steady on to finish off the end here. It'd been drilled, but I hadn't faced it, so I'll just face that off now. So I'll put that in there to hold it while I was facing the end off. I didn't screw cut it with that in place. Right, let's do a little bit more, take this down, and then we'll crack on with the next bit, which will be fun.